Hello everyone, I'm Dr. Harper. This video is an Operations Management BANA 3000 Spring 2021, and this is going over homework number 2. So this, the design and the homework, the workflow that I designed for this course is first I post the lectures, I post the homework, and you work through them. But then I will do this video to cover the homework, and you can see what you've done, see what I've done, compare the two before you turn it in this Sunday. Okay, before you turn it in when it's due. And so this is going over homework number 2, where you find the answers, and how to work some of the problems, how to set it up. And so I won't work them all the way through, but I'll set it up so you can see how to work them. So let's bring up the homework assignment. Okay, questions on homework number 2, forecasting. And so as we come down here, we have all of these videos. Now, all these videos you don't have to watch. I think I said this is 12 hours and 20 minutes of video instruction. You know, over the years, I just keep putting more and more on, but only a few of these do you watch for the homework. And if you notice, a lot of times I'll say which video should you actually watch for these questions. For example, question 1. Which letter indicates the number of statements that are true in the set of statements below? So there are 4 statements, and how many are true? You count up. Are all 4 true? 1, 0? So how many are true? But I say use video 1 under the forecasting heading. Well, if you bring up Canvas, so let's bring up Canvas, and here's Canvas. And if you look on the very home page under the website, mdharper.com, opens a new page under Operations Management tab, and we come down here, videos, forecasting, this Introduction to Forecasting Video 1. This is what I'm talking about. You click Video 1, it opens a new page. Welcome to the Harper. Through it here, but you go through this, and this pretty much answers all the questions, and actually I present it. So these are called lectures, but they're really presentations, okay? And so I have the closed captioning on, so you have closed captioning too, and actually closed captioning can be in different languages as well. Anyway, so that's what I mean by that. So let's go back here for video 1. So so the stationary time series and will never contain. So all of this is answered in that video. And so these questions say look at the video with these questions side by side if you want. And all of the answers to these questions, whether true or not, should be in that video. Or you should be able to see them in the video, because they are there. Okay. Question number 2. 2 through 5, again, video 1 in Excel, number 1. So you go back to the mdharper.com, the Operations Management, and notice I have, you can download, you can open the video and watch it, but right under that is an Excel file. If you click the Excel file and open the Excel file in a new window, and you download it here, open this thing, and there it is. So now what I've done is I've actually calculated, here I calculate the moving average, I do the exponential smoothing, I do regression here, and seasonal indexes. A real simple spreadsheet to go through and show you the equations I use to do each of these. Here's exponential smoothing, the equation I use to do each of these. Okay, and so you have those there for you to go through if you like. Okay. Now let's go back again to the homework. Here we go. But then again, consider the annual time series using a 2-point moving average. What is the forecast for time period 9? Okay, well, let's bring back Excel, and let's go ahead and open a new file. Let's minimize that. And so let's use a new file here. And let me just show you how to work these. I've showed you how to work this in the lecture. Now this is a lecture on the homework, and I'll show you how you would do it. Okay, so let's take the years here, come down to here, Control C, copy. Let's bring the Excel file back, and then let's come down and give it some space here. Control V, paste. Okay, and then I'm going to copy it again right click and paste just the values to make sure I only get numbers. Okay, now I want the here I want the 2-point moving average. So what I want here is an MA2, so 1, 2, so the average of the 2 previous time periods will be the forecast for that time period. The forecast for time period 3 is the average of the 2 previous time periods. Press return, and so you can come down here, the lower right here, and should copy this down all the way down to 9 here, and that is going to be your answer. Let me oh, I'm here. Okay, there we go. I won't do that for you. I'll let you finish it up. Okay. Now, question number 3. Consider the monthly time series. And if you notice, the time series are the same. I just say it's monthly now. Using exponential smoothing with a parameter of 0.84, what's the forecast for time period 9? Okay, let's bring back Excel. Actually, let's move this up a little bit so we can have enough room for Excel. Bringing Excel, there we go. So now I want exponential smoothing, but my parameter is 0.84. Okay, that's alpha. So if I say, this is how I like to do it, I'll say equal this, then copy this all the way down. Okay, and now, in order to do exponential smoothing, if you recall from the lecture, the forecast in the second time period equals the time the time series in the first time period. Let's delete that because it's not years anymore. Okay. Now the forecast in the second time period equals the data in the previous time period times alpha plus 1 minus alpha, close parenthesis, times the forecast. And so notice how I have blue here. Let's make this a little bit larger. Can't do it. Blue here is that cell. F4 is that cell. F4 is that cell. And E4 is the purple, that cell. And so if I do this, again, that's my forecast. And then I can copy this down. Likewise, I copy this all the way down to here. And that's going to be my forecast. That's going to be the answer. Let's make this, I like Arial. You'll see here Arial is much bolder. And let's center it. Everything is centered. Okay, and so that will come all the way down to here and you'll be fine. Okay, so that's question 3. Question 4, consider the weekly time series using simple linear regression. What is the forecast for time period 9? Okay, let's bring that in here. And now notice it's the same time series. Okay, so let's do regression. Well, with regression, you'll need an intercept and you'll need a slope. Okay, so here, this is going to be regression. But over here is the intercept. Let me just say, let's say intercept. And this would be the slope. Slope. Okay, and this is my function, intercept. And here I'm going to have my known y's, which will be these. That's what I have here. Let me go ahead and fix them. F4 to fix, the dollar sign means they're going to be fixed, comma the x's 1 through 8. Just to fix them, to be careful. So there's my intercept. Then over here's my slope, equal SLOPE. The known y's are going to be these. Fix them, comma. The x's, F4 to fix, close parenthesis. Now, again, like I say, the way I like to do it is I want to see exactly, exactly what I have here. Okay. And that's going to equal that number there. And then I'll just copy this down all the way down to time period 9. So now my forecast equals the intercept plus the slope times the, make sure these numbers are right. Times my time series, the actual time period. So I press return, and then I copy this all the way down. If I copy this all the way down to 9, that's going to be my answer, and that's how you solve that one. Okay, good. We're on a roll. Let's do the next one. Number 5. Consider the quarterly time series using the seasonal index approach. What is the forecast for time period 9? Okay, it's quarterly. I want time period 9. Again, let's come back. Let's look at this and say it's a quarterly time series. So therefore, if it's and I want the forecast for time period 9 again. If it's quarterly, what that means is every 4 time periods is a year. Being. Every 4 time periods is a year. Being. So let me take the time series here, Control C, and let me copy it over here. Okay, and then let me move over here. So since it's a, as I said, since it's a quarterly time series, every 4 quarters is a year. So this is 1 year. Boom. This is another year. So let me bring this up here. This is year 2. Boom. And then the 9, 10, 11, 12, this is going to be year 3. Boom. So if I want the forecast for time period 9, isn't that what I want? Let me make sure. Forecast for time period 9. Yes, I do. Time period 9. Okay, then I want this forecast right here. Correct? Well, since it's a stationary time series, all I will do is take the average of this number, comma, and this number. In parentheses, return. If you return, that's going to be your answer. I'll let you do that. Okay, and so that's how you work that problem. Okay, next. Question number 6. Oh, now using video number 10. Okay, why is it 10? Oh, I'm looking at forecast accuracy measures. Okay, let's go back to here. Let's go back to the website. Operations management. Come down here, video 10. Hello, where's it at? Here it is, video 10, forecast accuracy. So you look at video 10, and this will tell you everything you need to know about forecast accuracy with Excel. I even go into Excel and show you how to do an Excel. Okay, somewhere. Probably down here at the end somewhere. There it goes. I go into Excel. So this is what the homework is. This is exactly what I'm doing in the homework. Okay, so let's go back. And let's do it. Okay, consider the annual time series. So now we have annual time series again. An annual forecast of 235 was used for all the years, including year 9. Forecast accuracy measures based on window of 3 were obtained. Consider the set of statements for the forecast year 9. Okay, the mean deviation. So I say 2 things here. The first thing I say, is what's the value of the mean deviation? Mean absolute deviation, the tracking signal. But then I say which is a measure of. Now, is the mean deviation relative bias? Is this absolute variability? Is this absolute bias? So there's 2 things on each of these statements. Is the number right? And is the description of the measure right? Measure. The tracking signal with a window of 3 ranges between between -3 and +3, and that's a definition of the tracking signal. Again, that's in the video 10. Okay, so let's do this. We have a forecast action measure window of 3, and I want the mean deviation, mean absolute deviation, and tracking signal for a window of 3. So let's bring back Excel. And here we go again. Okay. Let's come back here and let's take the time series, Control C, copy it, and then bring this over here to the right of this, and then copy this, paste the values, and there it is. Okay. So now I want, and notice, and actually the annual forecast of 235 was used for all the years, including year 9. So my forecast here is 235 for all the years, including year 9. So that's my forecast. So now, let me get the deviations, D minus F. But it's a window of 3, so I'm only looking at these last 3 down here. Let me box that in. That's all I'm looking at. So let's go equals D. So this is D. Whoops. This is D. That's my demand series. Okay, this equals D minus F, and I copy this down, so I got 3 of them. Okay, now the video 10 and even the lecture, so you have 2 different places you can look. One is a lecture explanation, the other is a video, which is a presentation. This is going to be an application. Okay, and so what I want here, I want to track the mean deviation, mean absolute down here. I want the mean deviation, I want the mean absolute deviation, and I want the tracking signal for each of these values. Let me get to my, here we go. Okay, so this actually is going to be this one, mean deviation, mean absolute deviation, tracking signal, TK, I did L instead of K, there we go. So what we do is we sum, okay, equals sum of all of these. I'm gonna go ahead and do this, and then I want the absolute value. A, B, S is absolute value of each of these, which just takes away the minus sign, is all it does, and copy that down. Boom, boom, and then sum that. Okay, and then right here, I'm going to take the average. And that's going to be the average, that's going to be the mean deviation, that's going to be the MAD. Now the tracking signal, I'm going to move this down here. The tracking signal is going to be 5, that's going to be 5 divided by MAD. It's going to be 5 divided by whatever that number is. I'll let you do the arithmetic, but that's how you calculate it. So those 3 numbers are the 3 numbers that go mean deviation right there, mean absolute deviation MAD right there, tracking signal right there. So those 3 numbers go right there. That's the first part. The second part is the mean deviation a measure of relative bias? Is the mean absolute deviation a measure of absolute variability? Is the tracking signal a measure of absolute bias? Is the tracking signal with a window of 3, does it range between a -3 and a +3? That is explained in the video. Watch the video, it explains it very well. Okay, so that should be those 4. Okay, how are we doing here? 7 through 9. Now we're toward the last 7 through 9. So now I go to, this is video 1, Excel file again, but video 2 and video 8 under the forecasting heading. 2 and 8 talks about seasonal indexes and everything. Okay, so the idea here, now 7, 8, 9, I go to a scenario. Okay, we've done the mechanics. Now it's progressional. Now we're coming to a scenario, which is a business scenario, which is not unlike things that you would do in business. An international distribution company of containers has operated 5.2 million unit capacity warehouse in Manila to service customers between the Asian continent and the North American continent for the past 4 years. Leanne Abel, VP of Logistics, sent the quarterly time series, which are the number of units in thousands serviced through the warehouse, to 3 of her analysts and asked them to bring forecasts to the next planning meeting for discussion. Leanne convened the meeting and asked each analyst to report. And here's the data. Now, containers. Some people sometimes are not familiar with containers, and I'm going to take a chance here. Since I'm not going to show you. Let me off screen. Let me see if I can find. Let me see if I can find pictures of what they mean by containers. Oh yeah. Oh yeah. Boom. What they mean by containers is that they're not like a little container. These things can be huge. These are containers right here. These are containers. And there's a container, like here's a container yard. Okay, logistics, import, export containers. Let's look at this one. You see a container here. Whoops, I want to see the big picture. There we go. So this is a container. And so they have a lot of values and thousands of values in here, okay? And these are containers in a container yard. If I can, let me see if I can show you a container yard. Okay, and some of you may, if you're in logistics, you certainly might see a whole container yard from an aerial view. There are hundreds of these things. Well, here's getting close. If you can see an aerial view, this is not. Oh, here's kind of an aerial. Oh, here we go. So this is an aerial view. Is this a railway? I think it's a railway of containers. Shipping containers. 5 frequently asked questions. Okay, you can't see it, but there's a bunch of them. Okay, so I just wanted you to know what I'm talking about here. Because there we go. This is what I want to show you. Look at this. Hello. Here we go. Open, open, open. It's not going to open for me. Let me just. Anyway, if you can see that, look. It's a yard. It's a container yard. So we're not talking about a little container that you put your fruit in. No, this is a huge thing. Okay, that's enough of that. Let's go back. There's another one up here somewhere. There's an aerial view. There's one. Okay, you get the idea. Okay, so she says, so these are in thousands, I think. Okay. So here's the last 4 quarters for last 4 years, the quarterly demand for the last 4 years. And so Leanne Abel, VP of Logistics, sent the quarterly time series, which are the number of units in thousands. Okay, and this is in thousands, so this is 2.8 million. Serviced through the warehouse to 3 of her analysts. And notice the analysts is Amy, Bob, and Carl. ABC. Amy, Bob, and Carl. And so now it says, okay, Amy assumed a stationary time series with only a random component. So on these questions, I'm not asking you to solve the problem. I'm telling you that Amy, Bob, and Carl solved the problem, and they made these assumptions. If they make these assumptions, then what would they get? Amy reported using a 3-point moving average. What did Amy report as the forecast in thousands for the first quarter of year 5? So I'm not saying solve it. I'm saying how would Amy solve it if she assumed a stationary time series with a random component and a 3-point moving average? So let's take this again. Control C. So you have to solve it the way Amy did based on her assumptions. So let's bring back Excel. And this time let's open a new spreadsheet and come down here and put this in. Boom. Okay. And then paste it there. Okay, let's make this larger. Okay, there we go. Okay, now you have to be careful with assumptions. Let's bring this up here so we can see what we're doing. Bing, bing. Okay. There we go. Okay, Amy assumed a stationary time series with only a random component. So if you have a stationary time series with a random component and a 3-point moving average, how do you apply that? You apply it to the last 3 data points in the time series. Well, year 1 has quarter 1, 2, 3, 4. Year 2, year 3, year 4, 1, 2, 3, 4. So what's the last 3 data points? It's going to be these 3 right here. So if we bring back Excel and say, okay, the last 3 data points for year 5, let me put 5 in here. Let me just say 1, 2, 3, 4, 5. And let's, again, center this. I like everything centered. That is going to be the average of the last 3 data points in the time series, which is going to be this, this, and this. In parentheses, return, and that's what Amy would report. I'll let you do that. I won't do that for you. Boom, boom, and I'll let you do that. Let's shade that because that's taken. Okay? So that's the answer to 7. Now 8. Bob assumed a stationary time series with a seasonal and random component. What did Bob report as a forecast in thousands for the first quarter of year 5? Oh, okay. So if he has a stationary time series again, but if it's random and seasonal, when it's seasonal, the seasonal, let me bold that. Seasonal is a clue to block the data. You block it. Blocking it means just stacking year 1, year 2, year 3, year 4, because then quarter 1 is together. Okay, so let's go ahead and take another row down here for year 5. And so now, if we want the forecast for the first quarter of year 5 here, we average these numbers here. So let's go back to Excel. Okay, so now let's year 5 for Bob. This is going to be the average of these 4 numbers, 1, 2, 3, 4, in parentheses. And when I press return, that's the answer for Bob. Okay, so I'll let you do that. Okay, so this is 5, Amy, and this is 5 for Bob. Okay, let's darken that, and let's make that a little darker. Okay, now I want Carl. Okay, Carl comes and says, Carl assumed a non-stationary time series with a linear trend, seasonal, and random. So he has all 3. What did Carl report as a forecast in thousands for the first quarter of year 6? Year 6. Year 6, not 5. He's looking at first quarter of year 6. Okay? So let's bring back Excel. So now, since we're looking at, whoops, bring back Excel. Okay, now, so now we've blocked it. Let's look at this thing. Well, let's go ahead and do it. If he is assuming a seasonal, and he's assuming seasonal, since he's assuming seasonal, what do? We block it. Okay, and so we already have it blocked. There it is. But then he assumes a linear trend, and there's a linear trend. Well, let me darken that. When you have a linear trend, then what do? Then between the years, you look at a slope and you regress. You don't really, you block it, but then between the years is not random. Between the years is a trend. So now we're going to have 5 for Carl, but we also have 6 for Carl. And what we want is 6 for Carl. Okay, so let's block in that. Let's darken this with something. Let's make this one, since we have this here. Let's make this blue, and let's make this one red, since we can. Yeah, there we go. This is what we want. But then again, how do we do that? Well, there's where you take the slope, you take the intercept, you do regression. We've already done the arithmetic, the mechanics. It's just knowing when to use what mechanics where. So let's do it here. Okay, let's make this large so you can see it. There we go. So let's do it. Okay, equals the intercept, intercept, of the y values, which are these, 1, 2, 3, 4, comma, the x values, 1, 2, 3, 4, in parentheses, plus the slope of the y values again, comma, the x values again, and there we go, okay, times, now what year is it? 6. So times 6. Press return and you have the answer. That's what Carl would report. Now if I put 5 here, that's the forecast in Q1 of year 5. If I put 6 here, it's Q1 of year 6. And that's what Carl reported. Press return and there's your answer. Okay? So, which one of these, so let's come back to this. So that's 7, 8, 9. So which one of these is correct? Well, each of these assume 3 different assumptions. And different assumptions led them to a technique. And the technique would lead them to 3 different answers. And so doing forecasting depends not just on the arithmetic, it depends on your assumptions, how you've decided what the forecast, what the type of time series it is before you start forecasting it. So you have to say, do I have a stationary time series? What are my components? Then my technique, then the mechanics. For example, let's bring back Excel before we leave here. Since we're right here with the data, it's kind of like right here. Let's bring this back down a little bit. So let's look at this. Let's look at this right here, and let's plot this. So we can come over here, insert over here the charts. Let's see if I can get this chart. Oh, wow, look at that. Wow, year 1, 2, 3, and 4. Look how close they are. They're extremely close. But if I could enhance this, if I could go from 1,000, well, I'm in thousands here. If I go from 1,000 to 5,000, let's bring this down. Okay. Let's see here. Let's go to over here. Double click this. And let's go the maximum. The minimum is 1,000. And this is 5,000. Okay, I can spread it out a little bit. So it looks like it's going up. There's a slight, notice 1, 2, 3, 4. 1 is blue, 2 is orange. It goes a little bit higher. 3 is gray, a little bit higher. 4 is gold, a little bit higher. So it does go up slightly. So there is a little bit of a trend, but it's not a lot of a trend. But there's certainly seasonality. Seasonality is correct. But there is a slight trend. But if you go to year 6, this is year 4, 5, and 6, it's going to go be higher. So if you assume a stationary time series, you take the average, which is right in the middle here. That's the forecast for years 5, 6, 7, 8, 9. But if you assume a trend, it's going to keep going up. So I don't know. I think, which one do you think is right? I don't know. I'll let you decide which one you think is the more accurate. Okay. Question 10. Now, the last question here, I'm saying, okay, I want you to decide. Well, question 10 is really the only real business question in this whole homework, because these are the kind of questions you'll actually get in business. Rarely do someone say, oh, assume this, use this. They'll say, At the end of the fiscal year, a consulting company wants a monthly forecast. Give me a forecast and give me the best forecast you can for the number of contracts next year. They collected monthly data for the last 5 years. If you were working for my consulting company, if you were working for me, I know what you know. Which set of forecasts would I accept as the best monthly forecast for next year? So I have 4 different sets. Which one is the best? Well, what I mean by this is that I know what you know, and let me show you what I would expect you to do if you were working for me, and something you should do when you start working for someone else in a company, when you have this kind of data. Okay, first, plot the data. Okay, let's take this here, Control C, copy this. Let's go back to Excel. There we go. Let's open a new spreadsheet. Come down here. Let's paste it. Okay. And then let's Control C. Copy the pages here. And I think I have years here, months here. I'm not really sure what I'm going to get here. I don't know. Let's see what I have here. If I insert and a graph like I did before, let's see, what do I have? I have year 1. Yeah, I got the years here. I got year 1. Okay, look what I have. This is nice. This is really nice. Let me make this big so we can see it. Okay. Year 1 is blue. Year 2, year 3, year 4, year 5. Okay, we can see this is a stacked plot, and we can see every year the values are increasing. That's a trend. But also look at the pattern. The pattern every year is the same. That's seasonal. So I plot the data, and I can see I have a seasonal component because the pattern repeats every year. I also have a trend component because it increases every year. Okay, so I see that. Aha. Now that I see that, now I know I want to stack the data. I want to block it because it's seasonal, but I want to take the trend between the years because there's a linear trend. So let's move this out of the way. So here's my months, here's my years. Okay, so now I want month 1 for year 6 over here. So what I'm going to do here, I'm going to have, let me just put, instead of having the years up there, let's have 1, 2, 3, 4, 5, 6. Okay, for year 6 here, I'm going to say, I've blocked it, and so I want the forecast here. And so that's going to equal the intercept of my values, my time series, comma, my time, F4 to freeze it. Oh, these are in the way. There we go. All of these, F4 to freeze it, because I want to keep those constant and get the intercept for all of these for each month. Okay, in parentheses, plus the slope, same thing, the time series, comma, and the time, F4, okay, in parentheses, times, and this is in the way, this thing here is in the way, times 6 times 6. So I press return, and you get the forecast for that month for year 6, assuming a linear trend and seasonality. I'll let you do that, but once you do that and get an answer there, then you come down here like this, and you copy that down, and you'll have an answer for all of those. And let's make that green. And there's your answer for this question here. And it'll be one of those, A, B, C, D, or E. Maybe it's none of the above. Okay, and so that's how you would do that. So all I'm asking for is what's the best forecast. And so if you go through this process of making sure, plotting it, deciding what you have, and then using the seasonal index approach with a trend, then you get these forecasts, and then you copy it over. And that's how you do it. Okay. And now sometimes you want to make a plot of this, and sometimes you say, wait a minute, I want to see the actual time series. Suppose you wanted to see the actual time series, not a stacked plot, but a line plot. It's not that hard to do. Okay, let's come down here, equal, so I want to take this matrix and make it into a column vector. So this is going to equal that number. This is going to equal that number. Okay, in other words, at the end of year 3, I want to copy year 4. At the end of year 4, I want to copy year 5. I was going to bring these down. Okay. Also, at the end of month 12, I want month 1 to start all over again. So now just notice what I'm going to do. I'm going to take this. When I copy this down, it's going to be copying all these things underneath it. And then copy these down. How far down do I go? Up. Oh, wow. I'll go down till I have no more, till I have zeros. Here they are. Alt-ED erases it, and this right here represents my time series. Let me make these aerial, center it, and let's say this is my time series. And then here I'll say Control-Shift down arrow, whoops, Control-Shift down arrow. Why does it just go to there? Yeah, I'll do it this way. Control-Shift up arrow goes all the way up to here. Oh, I see. Let me take this out of here. Let me take this out. Okay. Now let's do Control-Shift down arrow. It's not going to do it. Don't know why. So if I'm going to take all of this, Control-C, bring it over here to the right, paste the values. Now I can come up here and insert. I can plot my time series as a line plot. And there it is in a stacked, and there it is as a line plot. And so if you want to do a line plot, you can do it that way. So this is just using Excel to generate your reports, to generate a memo, to generate graphs, to have a presentation if you have a presentation in business. And many of you, if you work for a corporation and work for a VP or a director, and you might be given presentations. And so this is how you would do it. And I do this a lot more at the graduate level. But here we go. This is how you do it. This is the beginning. Okay. And then you start formatting these to make them pretty. When you give presentations in business, make them very, very attractive, because the more attractive they are, the more convincing they are. And then use the graphs and the attractiveness of your presentation as your argument, not your words. Your words support the graphs. That's enough. Okay, that's a different course. That's all I have for homework number 2. I hope this helps solving the homework. And so together, you can work it and then compare what I do, and hopefully you'll do well here this weekend on when you turn this in, when it's the due date and time. Make sure you turn it in well before the due date and time, because 11:59 p.m. the clock goes off. I think people have already gotten in trouble with that, so submit it early. And so that's all I have for today. Between now and the next time I see you, I want to urge everyone to take care, be careful, don't take anything for granted, be safe out there. And so between now and the next time I see you, take care.